Our next section in math on big ideas, 8.3. I'm starting with rise and shine, but for some of you that might not be the case. You might not be starting this first thing in the morning, Tuesday morning on April 14th. You might be actually starting it sometime in the afternoon, or maybe not even on Monday or Tuesday, sorry. You might even be starting it on Monday, but rise and shine is how I'm going to start this out with. But for those of you that aren't just waking up, getting out of bed and rising and shining, we're just going to say, let's do this. Let's get started. Look at how excited they are. Oh, Mrs. Priggy, I can't wait. I can't wait to get started. Here we go. 8.3 is called the quotient of powers property. And what that means is that you're going to be generating equivalent expressions involving quotients of powers. That sounds yucky. It's really, really easy. You're going to be so shocked at how easy this is, and you're going to be so excited that you've learned it. And so let's take a look at our learning targets right away, okay? You'll know that you know how to do this, that you're successful at learning it when you find quotients of powers that have the same base. Also, when you can simplify expressions using the quotients of powers property, and solve real-life problems involving quotients of powers. So when you know how to do this, when you can do those three things. And today we're going to talk about the first two. We'll do the next video on the last real problems, quotients of powers, successful part. Okay. So let's just kind of review. This isn't in your notes yet. I'm just going to kind of review what we're looking at. So we're looking at right here, we know that if we have a base raised to a power times another base raised to a power, those two powers are the exponents. And what this means, it's the same thing as multiplying the base, which is the x's, 3 times in the first part of this expression and 7 times in the second part of this expression. If I wanted to rewrite this and simplify it, I could simply just write the x raised to those two powers added together, meaning x to the 10th power. So with the same base, all I have to do is really add up my exponents and I can simplify that expression. Okay, this is the product of powers property, and we learned this in 8.2. And really what the product of powers property means is that when exponents have the same base and are being multiplied, you can just rewrite the base and add the exponents. Okay, you rewrite that base of x and you just add those two exponents together in the product of powers property. You need to remember though what that word product means. Product refers to multiplication. So if you have a product or two numbers, two bases, the same base being multiplied together, you are talking about finding their products. That's multiplication. But what if you're talking about finding the quotient? I like to think of the quotient as basically being the opposite of the products. The quotient refers to division. Division, of course, is everybody's worst nightmare because right away they're like, oh no, Mrs. Priggy, I'm only so good at multiplying, but when it comes to division, I struggle so much. Relax. Quotient in this case with exponents is way different than dividing numbers, okay? It is still division, and the quotient of powers property is similar, and I said it's kind of the opposite of product of powers because in the quotient of powers property, when you have the exponents with the same base that you're dividing, you rewrite the base just like we did up here with the multiplication or the products, and you don't add the exponents but you subtract them. So the next part of our video here is going to talk about what that looks like, and it's going to have you actually doing this in an exploration first. I'm not going to have you do this on big ideas. I'm just going to do it with you, and you're going to follow along, and I'm just going to show you how this product quotient of powers property actually works. So if you were doing this in the exploration one, it says to write this as repeated multiplication. So I have 2 to the 4th divided by 2 to the 2nd power. There's your quotient. It looks like a fraction, but it's really division. Fractions are division, as you know. So if I were to write this using repeated multiplication form, I have 4 2's, the base of 2, in the top part of my equation, or the numerator, and in the denominator I have 2 2's. Okay, this is the repeated multiplication form. And hopefully you know that when you're using this form, you can actually literally cancel out your 2's. If you have the same thing on the top and bottom, they divide by each other and they equal 1. 2 divided by 2 is 1. The other 2 divided by 2 is 1. So therefore you end up with just these 2 2's left, and to rewrite that or to simplify it, I can just write it as 2 to the second power. Once I cancel out those 2's, all that's left are the 2 to the second power here, so that I can simplify it in that way. Let's look at the next problem. -4th raised to the 5th power divided by -4th raised to the second power. Again, rewriting it in repeated multiplication, I have 5 -4's over 2 -4's. And again, I can use that cancellation. -4 divided by -4 is 1, so I cross those out. -4 divided by -4 is 1. I can cross those out. And what I have left then is 3 -4's, and I can rewrite that now as a base of -4 raised to the 3rd power. Notice how the -4 is in parentheses. The base is written exactly the same here as it is when I simplify it. The next expression is 7 to the 7th power divided by 7 to the 3rd power. What does 7 to the 7th power look like? Well, it's 7 7's divided by 3 7's. And yes, I can go through that same process of canceling out my pairs that would create or make 1 when I divide them away. And I have the 4 7's left. But remember back in the previous page I said that the quotient of powers property is really the opposite of the product of powers property, in that really to find this answer I don't have to rewrite these and write the expanded multiplication form. I can just simply subtract my exponents from each other. 7 minus 3 is 4, and then rewrite my base and solve that, simplify that expression. So I'm not even going to write the repeated multiplication of 8.5 to the 9th divided by 8.5 to the 6th. I'm just going to do the 8.5 to the 9 minus 6 to find that that expression simplifies to 8.5 to the 3rd. And lastly, 10 to the 8th divided by 10 to the 5th is the same as 10 to the 8 minus 5, which is 10 to the 3rd power. So as you can see, this proves the product, the quotient of powers property. It proves that if you just subtract your exponents, you can simplify those expressions, and they do need to have the same base though in order to do that. So in order to do this property, you need to have the same base to subtract your exponents. Now's the time to write in your notes, okay? So let's get started with that. And this just talks about the quotient of powers property and what does that really look like. And in words, the quotient of power property is to divide powers with the same base. That's key, the same base. You just subtract their exponents. You rewrite the base, subtracting the exponents. How that looks in number form, let's use a form of 4 to the 5th divided by 4 to the 2nd. This is just an arbitrary number, 4. 4 is my base. If I just subtract my exponents from each other, 5 minus 2, numerator minus denominator, I get 4 to the 3rd power. When you write it algebraically, all you're doing is writing in a variable instead of a number. And the reason we use the algebraic form is so that you realize that any number will work here as long as you have the same base. We'll do a to the m power divided by a to the n power. A is our base, so they are the same. So we show that just by showing the subtraction here. And because we don't have numbers for the exponents m and n, we just leave it like it is there. So I'm going to ask you now to stop the video, to write this in your notes. And then when you're finished writing in your notes, resume the video and we'll keep going. Okay, so we're going to actually do a few of these problems. We're going to do 3 examples, and then you're going to go into the try it on the dynamic student edition of Big Ideas, and you're going to actually try it on your own to make sure you get it right. Okay, so let's start out. 2 to the 6th divided by 2 to the 4th. First of all, they have the same bases. So I know I can just take my numerator exponent, which is 6, and my denominator exponent, which is 4, and subtract them from each other to get 2 to the 2nd power. Notice this common error here. When dividing powers, do not divide the bases. In other words, I'm not going to do 2 divided by 2 is 1 raised to the 2nd power. You keep the same base. The only thing right now you're changing is the exponent value. Okay? Okay, going forward for B, same thing. Negative 7 raised to the 9th power divided by negative 7 raised to the 3rd power, which gives me negative 7 in the parentheses, because I write my base exactly the way it's shown. The 9, the numerator, minus the denominator, minus 3. And to rewrite this, simplifying it to negative 7 raised to the 6th power, because 9 minus 3 is 6. Lastly, a base of h to the 7th divided by h to the 6th. How do I do that? Well, I rewrite it as the same base and subtracting my numerator from denominator, or my 2 exponents. 7 minus 6 is 1. And we don't have to write h to the 1st power. You could just write h. Either one of these would work. It would work for me, and it would also work on Big Ideas. So what you need to do right now then is to stop the video and go to this dynamic student edition, and you want to do your try-its. You want to do try it 1 through 4 just to see if you understand the concept and you're getting it right. You should also rate yourself when you do that. So stop the video here, go into student edition, and give it a try. If we were in school right now, I would say that this math is for sure easy peasy lemon squeezy, because it is. You all know how to subtract. In fact, you know how to subtract really, really well. It's the same base, and you're either adding when you're using the power of products property, or you're subtracting when you're using the quotient of powers property. So of course it isn't always going to stay this easy. Here's where it starts to get a little bit harder, but again, manageable. Right now, for example 2, in your notes, again, now we're going to be simplifying an expression. And they show the expression 3 to the 4th times 3 to the 2nd divided by 3 to the 3rd. So the first thing I notice about this is all of these numbers have the same base. So when I'm simplifying this puppy, it's going to be super easy, but I have more complex things going on here because I have the product of powers property, and I have the quotient of powers property. It's kind of a lot, okay? So the first thing I want to do is take a look at the fact that I have 2 properties going on. And because of that, this problem requires more than one step. It uses the product of powers property to simplify before using the quotient of powers property. So in other words, I'm going to do the product of powers to get this into one manageable quotient of powers property looking example. Okay, so let's do the addition part first, because these 2 numbers are the product of powers. They are being multiplied. I know when I'm multiplying 2 exponents with the same base, I add their exponents. So 3 to the 4th times 3 to the 2nd is really 3 to the 6th. And when I simplify that expression further, I just rewrite that denominator the same way, because nothing's happening to this. And now I have only the quotient of property, quotient of powers property. So now I can do my subtraction. 6 minus 3 gives me 3 to the 3rd power. I don't know where my 3 went. It's here somewhere. There it is. Oh well. Okay, there it goes. Okay, it gives me my quotient of powers property, and I am able to simplify that. Notice the base is still 3, and once I simplified the numerator, by using the product of powers, then I could do the denominator, the quotient of powers, and simplify the whole thing. All right, so this is where you're going to stop the video again. And there are 3 problems on Dynamic Classroom Edition for you to try. Enter your answers to those 3 problems, check it out, see how you do, and then rate yourself. Stop the video here. All right, so the one lesson we should have learned by now is that it always gets a little bit tougher. So I need you to do the first thing that you should always do in every math problem is examine it first. Look at that problem, see what it's asking you to do before you make any moves. You're going to be looking for properties before you simplify. You're going to be multitasking. Okay, not so difficult though. So let's look at our first example in example 3, letter A. You have negative 4 to the 9th divided by negative 4 to the 5th power times negative 4 to the 8th divided by negative 4 to the 2nd. I'm seeing quotient of powers. I'm seeing product of powers. I'm going to start this particular one by resolving or simplifying each part of this. I'm going to keep the multiplication in my expression and resolve that last. So I'm going to resolve the quotient of powers first. I'm going to subtract that 9 and that 5 in the first number, and then in the second one I'm going to subtract the 8 and the 2. Okay, I'm going to resolve the quotients of powers property first. You can do it either way. This is just the way I choose to do it. Okay, so I keep my same base of negative 4. Okay, and I also subtracted to find that power. I subtracted to find the second power, and now I'm going to use my product of power properties to add the exponents. All I've resolved is I've gotten rid of the division here. I subtracted to remove the division. Now that the division's gone, I have negative 4 to the 4th times negative 4 to the 6th. I know I can just add those 2 exponents together, and I get negative 4th to the 10th power. Okay? I know that that's how they resolve. Part B, a to the 10th divided by 6, a to the 6th, sorry, times a to the 7th divided by a to the 4th. Again, I'm going to do the quotient property first. I'm going to resolve this particular quotient, a to the 10 minus 6, and then I'm going to multiply it to the a to the 10 minus 4. I'm going to resolve the quotient of powers property first by subtracting. When I subtract those 2 exponents, I get a to the 4th times a to the 3rd. And then I'm going to use my product of powers property to finish the simplification here. 4 plus 3, I know, is 7. So simplifying these two using both properties in either order. You do not have to subtract first or use the quotient property first. You can if you like. If you want to add them first, you can. It's really your call, but you just need to rewrite it each time so you know you actually you keep some kind of order in it. So if you do make a mistake, you'd be able to find your mistake. All right, again, stop here, go to the Dynamic Student Edition, and try these 3 problems in there to see if you can understand, or you can try these on your own. See how well you do. Rate yourself. Okay, stop the video here. All right, yes, you got this. You thumbs up, hopefully, or maybe you're not getting it, you need some more practice. You can always do skill practice on big ideas as well. It's there. Some of these are a little tougher than others, so maybe you go back and you determine which ones you need more help with. But once you do that, your assignment for this portion are these 7 problems. It's 8.3, the self-assessment for concepts number 11 through 17. It's in the Big Ideas assignment for this week. There are 2 of them. There's this one, and then there'll be an 8.3 exercises as well. But you are ready to go. So go for it. Stop the video will stop because it's over. And get this done. I know you can do this. I'm proud of you. You guys have come a long way since we've been out of school. Be sure to watch the next video lesson to finish 8.3. Good luck.